All right, so we're going to look at exponential and logarithmic equations and how to solve these. Today we are going to strictly look at how to solve the exponential equations like this. Okay, and we have, Jacob, put your phone away. We have done some of this where we may have taken the log of both sides, but what we want to look for when we have exponential form of equation is we want to look at the bases. So I'm going to compare the base of 1/2 and a base over here of 4. Remember, the base is what's being raised to the power. So we want to look at the bases and think to ourselves, is there a common base that we could write both sides of the equation in? Okay, so these two values, can I write them with the same base? When I look at 1/2 and I look at 4, I think of the number 2, right? 4 is 2 squared. Is 4 the same thing as 2 squared?
Yeah.
Yes. So really I can rewrite 4 as 2 to the second power, and then that's raised to the power of 3x. Now, earlier in the year we talked about rules for exponents. When I have a power that's raised to another power, how do I simplify that? I multiply them in that situation. That's right. So on the right side, I'm going to have a base of 2, and then I'm going to multiply the powers and get 6x. So we took care of one side of the equation. I took care of that side first because I think 4 is easily thought of as 2 to the second power. Now, can I write the number 1/2 with a base of 2 also?
Yeah.
I can. 1/2 is the same as 2 to what power? It's going to a fraction, right? So that's a negative exponent. It's actually a negative 1. 2 to the negative first power is 1 over 2. And then that exponent is still x plus 7. And again, I apply the same rule. When I have a power raised to another power, I'm going to multiply the exponents. So this is going to become 2. When you multiply, you have to distribute. So negative 1 times x and negative 1 times the 7.
And then that's your answer.
I'm not done yet, but we're getting close. What we're trying to do in this unit, in this section, is we're trying to write both sides of the equation using a common base. So now I have a common base of 2. If the base is the same and they're equal to each other, what does that tell me about the powers? The exponents. They have to be equal to each other. So now I can just say this negative x minus 7 has to equal 6x. I can eliminate the base part and I can just set the powers equal to each other, and that's an equation I can solve. I'm going to add x to both sides. So negative 7 is equal to 7x, and I'm going to divide by 7. So negative 1 is equal to x, and I have solved that equation. Okay, here's the second example on that packet. This is letter A. It says 25 to the 3x power equals 125 to the power of x plus 2. So the challenging part for you is going to be, what's the common base? When I compare a base of 25 and a base of 125, the common base is 5. So I'm going to rewrite 25 as 5 to what power? Second power. So I've just taken this 25 and I rewrite it as 5 squared. It's still raised to the 3x power.
For the other one, when you do 25 squared?
25 squared would be...
Oh, wait, no, that's 5.
So it's going to be 5 to what power is 125?
25.
3 cubed.
Oh.
5 cubed is 125. 5 times 5 times 5. And that's still raised to the power of x plus 2. So we've got our common base. we have to apply our rules for exponents. So this is going to be 5. If I multiply here, I would get 6x again. On the other side, base is 5. And again, when you have to multiply here, make sure you distribute the 3. So you're going to get 3x plus 6 for an exponent. Now that you have that common base, you're just going to set the exponents equal to each other. And you're going to solve that. So I would subtract 3x from both sides and divide by 3. X equals 2. You solved it. Last one. How would you, first of all, does anybody know what the common base is?
1.
It's not 1.
0. -1. I don't know.
How would you verbalize that value to someone?
What, 1,000?
It's 1,000th, right?
Yeah.
This is the 10th, 100th, thousandths. So that is 10 to what power? 1/1000th is what that is. So it's 10 to the negative third power.
So it's negative because it's a decimal.
Because it's a decimal, that decimal is that fraction. That's the equivalent fraction of that decimal. So that's 10 to the negative third power equals, on the other side, I've already got a base of 10, so I don't need to change that. So since the base is now common, I can just set the exponents equal to each other. And when I solve, I divide by 6. X is equal to a negative 1/2. As you look at your problems on your worksheet, you got to ask yourself, what can I write? What common base can I use to express both sides of the equation?